So we're going to start talking about the mean as the first measure of central tendency. In the world of statistics, it's also usually the most important one. It's the one we rely on the most. So it's a very common measure of central tendency, and it's a very useful measure of central tendency. But as we'll see later in other videos from this chapter, it's not always the best, but usually it's the one we want. So this is the one that, again, most students have been calculating an average since elementary school or so. How do you calculate an average? Well, you add up all the scores you have, and you divide by the number of scores there are, right? Well, we have symbols for all that now in statistics. So we can write all that down in our statistical set. We already know all the symbols we're going to need except for the ones to represent the mean itself. So one formula or way of writing the calculation for what we just described looks like this. So let's come back to this. Just look at the numerator here. Summation of raw scores. Add up all your raw scores and then divide by the number of raw scores you have. This is a capital N, so we know capital N for number of scores is associated with populations. This symbol over here is another Greek symbol. This is a capital M, as in mean, for the Greeks, a capital M. Its name is mu. So, but again, remember, use the words, not the names of the symbols. So what you don't want to practice is saying mu equals sigma x divided by m. That doesn't mean anything. But the population mean equals the sum of the raw scores divided by the number of raw scores. Ta-da! Now it means something, right? So this would be the symbols we would use. At this point in the course, every chapter forward, when you see a Greek symbol, you know it's referring to populations. Sigma is a bit of an exception. It's its own calculation thing. But any symbol we see that's written in a Greek letter is telling us it's describing a population. So that's why I said the population mean is the summation of raw scores divided by the number of raw scores. Writing the same thing for a sample, we're just simply going to substitute out the Greek letter for the capital M from our own alphabet. The sample mean is the summation of raw scores divided by the number of raw scores. It's the same calculation, right? This and this are identical. The only thing that's changed is these symbols tell you it's a population. These symbols tell you that it's a sample. For this chapter, it doesn't make any difference. Population, sample, it's all just adding and dividing, if you will. It's the same. Now that will change starting in the very next chapter. In chapter 4, the math sometimes will be different for a sample than it will be for a population, sometimes. But we're not there yet. So for us at this point, population, mathematically indistinguishable. It's exactly the same. So I don't think this is something I really have to spend any time teaching you. There's certainly examples that you can calculate means from in the book. Adding and dividing, it's pretty straightforward. But so what I am going to talk about is sort of the flip side of that. If we think about either one of these formulas, it's written in 3 pieces. Piece on the left, the numerator, and the denominator. So typically what you would be given is the raw scores. You would add them up. You'd count them to see how many there are. You would divide it and solve for the mean. But for any formula, if you have all the pieces but one, you can solve for what's missing. So what you need to make sure that you can do, in addition to just taking a set of raw scores and calculating an average for it, is working it around the other way. So let's say that what we know is that for a sample, we'll call it a sample, but again, it wouldn't matter. We have a sample that has a mean of 8 points. And we know that the summation of raw scores for the sample, summation of raw scores for the sample, we'll say is 40. And what we want to know is, well, how many scores were there? So it's simple algebra. There's a little handout for this inside of Canvas called Working the Mean. to give you a little bit of a refresher course if you've forgotten how. But in the end, you plug and play. Plug what you have into the formula, solve for what you don't. So we know that the formula is sample mean is the summation of raw scores divided by the number of raw scores. So we know that 8 equals 40 over little m. That's what we're trying to solve for. So, it's basic algebra. You're going to cross multiply and divide, basically. I'll semi-walk you through this one just because it's the first one, right? So we cross multiply, and we know that 8n equals 40, so we divide both sides by 8. And you find that the number of scores is 5. That's not something in a real world sense. That's not something that we practically have to do very often. Generally, if you have access to the mean and the summation of raw scores, you know how many scores there were. But it's something you should know how to calculate. Let's do a different example for something that actually has a little bit more use, particularly for us in the class. Let's say what we know about this sample instead. We know the mean, we'll say, is for the sample is 10 points. And now we know the number of scores. Let's say we know the number of scores was 4. And what we want to know is, well, what was the summation of the raw scores? What was the grand total of all the scores to get us there? So again, that's what we're trying to figure out. Plug and play. Put in the formula what you know, solve for what you don't. So once again, the mean is the summation of raw scores divided by the number of raw scores. The mean was 10. Summation of raw scores is what we're looking for, divided by 4. Again, cross multiply, and you will find that the summation of raw scores is 40. That's something you'll need to do from time to time. Notice that for this one, all you really have to do is multiply the other two pieces together and you're done. So to get the summation of raw scores, just multiply the number of scores and the mean together. But if you can't remember that, and really it's kind of a rule for the whole course, when you're stuck, write the formula down and plug and play into it. One of the mistakes that students tend to make, particularly as the course advances and they start to feel maybe a little more confident, is they stop writing the formula down first. And now they're plugging crazy numbers into a formula because they're not seeing it. They're putting the wrong scores in and they're calculating and of course getting the wrong answers. So the formulas are basically always your roadmap for what you're working on. It's your touchstone to reality for what you're trying to accomplish. So sometimes just writing it down and speaking it is all you need to do to get the job done. So all of that is conversation just about the mean. Again, what you and I would call in everyday world an average. Here is called a mean. So there's nothing really extraordinarily new about the mean, again, since when you learned about it when you were 8 or 9 or something probably. But we do have plenty more to talk about to take this a little deeper. So we're going to move on to talking about something called the weighted mean in the next clip.